say a few words first from our sponsors at Vaco. Introduce Molly.
Hi guys, I'm Molly Wilkinson. Some of y'all I've met. I'm a tech recruiter here at Vaco. I've met some of you guys, others I haven't. This is my virtual business card here, so if you scan it, it pulls up my contact info. But yeah, same spiel every time, but if you're on the job hunt, know of people who are looking or need resume assistance or just kind of want to learn more about what the market looks like right now, happy to chat with you. We do talent solutions here at Vaco, consulting and staffing practice, all the things. So happy to get connected on LinkedIn or chat with you. So feel free to reach out. Thanks for coming.
Also want to say thank you to Repton Tech, who is live streaming tonight. Everybody say hi. Interesting, informative, educational, from Warren Sadler. Let's give it up.
Yeah, accessory. Let's see. All right. First.
Oh, I forgot to mention one thing. If you guys have questions, please raise your hand just so we can run over with the microphone to get it on the stream.
Yes. Right. And so to that point, absolutely love to keep this informal, open. I really hope this is more of a workshop where we can just kind of talk through Effect. I see some laptops, and so if you want to try it out, that's really the goal here. Get hands on keyboards and mess around with Effect because I'm pushing it. I don't have any sort of sponsorship with them. Just really like functional programming, and I think it's a great library. So just that. Like Brett said, thank you to Vaco, NashJS, just a great community. If this is your first time attending, I hope you come to these more. Really great place to just get exposed to the community, the scene, and then of course Repton Tech for making this accessible to more people online. I'm the CTO and co-founder of Therify. We're a mental health matching company. Former cloud consultant at McKinsey. Before that, worked at Asurion, and before that, as a data science engineer at HCA, but I say prisoner of JS. I just love it. I can't get away from it. No matter what I do, I always find my way back to it, and therefore TypeScript. But today we're going to be talking about Effect and just a brief overview of how we're going to move through this. Try to make a case for Effect. I think there's so many libraries out there. JavaScript developers were used to a new framework, a new library every single week, but I promise this is the one that's going to stick, I swear. And so make a case for that. We're going to talk about actually creating effects. What does that mean? Performing operations on them. And then we'll try to make a trivial, but still, I think, informative application using EffectTS. All right. So what is Effect? Realizing now, maybe all black might be tough to see, but we'll talk through it. But Effect is a powerful TypeScript library designed to help developers easily create synchronous and asynchronous programs. And so if we think about large code bases we've all worked on, as time goes on, that complexity can look like this red line, very exponential, getting sort of all over the place in terms of libraries, tools, and patterns. Effect is trying to consolidate that into a singular framework of approaching that problem, making things more linear. And so they call out all of these efficiencies. This is actually borrowed directly from the website, so I can't take credit for the language. But maximum type safety. We get to treat errors as types. Errors, if we think about it, they're kind of control flow in JavaScript, right? We use it just like we use if statements. We throw things. It's not really a value that we can manipulate. Effect lets us do that. Composable, reusable, testable, all the buzzwords. But also rich in the sense that it tries to combine more of those common operations that we're used to, manipulating data in one singular library. So you can kind of throw away the low dashes, throw away the axioses, all of that stuff, and use one library for this thing. And if you're used to working in distributed applications, they are working on clustering and workflow. So what does that mean? If you work in like a distributed environment where different machines have to coordinate, Effect has some tools for you there too. So I put that there to say it's not just a toy, it's real stuff. And so we'll see a little bit more of that here in a second. But to that point, easily create complex programs. Complex. Where is that a good thing? And I think there's a distinction, really good talk from Rich Hickey, we were talking about a little bit earlier. Complicated does not mean complex. Complexity is almost essential to good software. In fact, we have to embrace that and say it's part of how we write really good software. We have to separate really what is incidental or essential complexity versus accidental complexity. And so we're going to try to separate those two terms and talk about those ideas. But essential complexity, these are things like our business logic, the relationship between data. These are kind of things that we really can't control. But then there's the accidental complexity, boilerplate code, incompatible APIs we have to make talk to each other, error handling. Someone threw an error, and it's like, we don't throw errors here, dude. We just try to exit early. Well, nothing about the language helps us prevent that from happening. Again, Effect tries to contain that. And so let's make an effect, okay? So if you guys, for those who are coding along, you can go to Effect website/play, and I'll put the actual big link on the screen, so if you are coding along, we can find that. So effect.website/play, and we'll have a handy dandy Effect IDE in the browser that we can mess around with. Can we see that? Is that enough size there? Okay. Let's create a very simple effect. We're going to call this guy my first effect. An effect, we can imagine, is really described as this type. So we put our cursor over it. We're already getting some really cool TypeScript stuff. We see this is an effect of void. We can sort of see that we call this method on effect or property on effect called void. And then we see these two other type parameters, never and never. What effect is actually describing is a program that results in a value. This effect isn't doing anything. It's void. The second type parameter is error, right? What are all the errors that your program could possibly produce? We're going to see this. It's going to be really cool. Effect really gathers all the errors, again, that your program could create and displays them to you as a union in that second property. And then the last bit, the never, the second never, is the requirements. And so effects are programs that, given requirements, result in a value or a union of errors. Okay, that's an effect. So we made one. If that feels underwhelming, it's going to get more impressive, I promise. But this is where we start. It's really that core definition of what an effect is. And so let's take a second to look at that type. This is the actual effect type definition itself. Like I said, it's a type that, given requirements of some kind, so these are dependencies your application depends on. This could be a third-party service, like a database connection, config from the environment, and it results in an error or a success. All right? And so let's take this a little bit further. We talk about success, we talk about error. Let's actually see that. We can succeed. We're already getting some really cool type handling right here. If we take a look at now the type, we see it's of type number. And so effect now is saying this effect results in a number, no errors. It's not really performing any computation, so no errors can occur. We don't depend on anything. And so we can actually fail. Notice the type changed again. This is an effect that results in a number as failure, so that error, they call these channels. If you look at the effect documentation, they call these concepts of success channel, error channel. These are things that are composed in larger programs that are building towards these ultimate results of your program. We see that here. But so how do you do something with this? I don't know how many people are familiar with, so I talked to some folks in the effect community around this. They were sort of mixed on this whole diatribe, but I think it's important. Monadic programming, monads, any concept, any awareness? Okay. So what monads are essentially containers. And in fact, I want to show you guys really quick how to emulate some of the things that Effect does, only so we can demystify really what Effect is doing under the hood and maybe appreciate all the things it actually is adding to the library. And so I'm going to be in CodePen. You don't have to go to CodePen. We can do this right here just for illustration purposes. And we're going to create something called a box. Very ominous, very ambiguous, but it's going to implement something called identity. Identity is a function that results in that same x. Okay? So now we're able to call a function and get a value out of a box, right? So let's see that. I'm going to say, example, going to be a box of 10. It's a good number. And so we're going to log this. And pretty obvious, we're not actually getting a value. We're getting, again, a container that references a thing. We can, however, call identity. And now we have our value. And so why might this be beneficial? Why might this be useful? Well, we're used to this actually with collection types, arrays. They represent something that's iterable in our program. But we gain some other superpowers with that too, right? We have iteration, control flow, for each, map, filter, all these operations we can perform on the data, but to the consumer, it remains an array. That's a very useful property. An effect is describing a whole application in that same context. We have a data type that represents our entire program. And so we can do things that we're used to. Map, before it was an array function in JavaScript, ES6, and that was pretty sick. It was a big deal when that dropped in JavaScript. But we've come a long way. But map, before that, was a concept, generally in programming, that took a function and applied that function on a value, right? So we're returning a new box, a whole new instance of the result of applying a function to the value inside of our box. If that makes sense. A little twisty. We're still tracking, still good. So what we can do now, let's take this a step further. Rather than doing identity, let's map. We can use an anonymous function, x plus 1, and any takers on what identity will be now when we call it. It's not a trick question. Right? So this is the behavior we're able to do with this chainable now operation. We can maintain the box, maintain the interface, and perform a sequence of operations on that data. Again, why is that nice? Imagine being able to describe a larger application in this same way. That's what Effect is doing for us. And so, with that, we can do the same thing in Effect. We can take our program, I'm going to succeed here, and like box, it has a special property, pipe. And we'll talk about what that means here in a second, but it allows us to describe a program. We're going to be able to get a value. We see the type signature, we're being passed a number. We can perform an operation on that number. And so let's try to log this, see what happens. Interestingly enough, Effect doesn't have a identity function because, again, we're describing not raw values, but a program, an application. We have to run effects, okay? And so this means it's lazy by default. You heard of like eager code, lazy code. Laziness is delaying computation until we need it. This is what allows Effect to do some really cool things in distributed environments. It doesn't call your function until it's actually needed. The value is needed. This is really good for like memory conservation, really good for coordinating threads or processes that are working in tandem. This is one of the powers, again, Effect gives us. But so to run this, to get the value out, we actually have to execute this. We can get our value. We can say effect.run sync. And so if we recall, the first slide, Effect is a library for creating synchronous and asynchronous programs. This is a synchronous program that does one thing. We establish a value, 10. We perform an operation by mapping on that value. And it's not ran yet. It's not run until we call run sync. That actually performs the operation. And so if I put my cursor on value, what do we think it's going to be? Let's find out. That's a number. Super cool, right? And so we were able to perform an operation on this data and get the value out. And so running our effects happen at the edges of our programs. So you guys think about, well, where do I start applying Effect, using Effect in my code base? You guys are familiar with hexagonal architecture patterns? This type of behavior happens on the edges of our programs. We use effects internally to describe operations on data, to pull external data sources and munge on them, and transform something, we call it at the edges. When is the client going to expect this data? This is when we actually use things like run sync. So threw a lot at you. We're going to take a step back and look at just this, just bring back some ideas. So again, effects are functions, right? Functions that when given requirements result in a successful value or errors, okay? And there's plenty of ways of creating effects. We saw succeed, we saw failure. There's ways of actually performing operations. That's what we're seeing here with sync, not run sync, a distinction. We can actually perform an operation using a function. And then really the most exciting stuff is promises, right? So effect calls them just promise. We can actually create effects from asynchronous code, right? And we talk about this idea of things that might fail. Let's see that real quick in our playground. We're going to define a program that's going to try an asynchronous action. We're going to fetch, I'll just do it because we're here. I'm going to fetch some Pokey API.co, API2/Pokemon. I don't know any Pokemon fans in the crowd, maybe not. No? Okay, might be the only one. But there's the very first Pokemon of all of them. There's like, I don't know, at this point, thousands of them. But the very first one is a Pokemon named Bulbasaur. And so we have a promise. We can see that this can result in a response. But we saw now, this is true of fetch everywhere, it can throw an exception. I think it's pretty amazing that effect is saying this can have an exception, right? Let's think about that for a second, like a JavaScript developer, you look at the type signature of a function, unless someone in the JS doc says this thing throws, you have no idea what you're picking up right there and about to call. I think it's amazing, even just unto itself, that we're getting a type that's saying this might throw. Pretty cool. And so we have an error because what we're trying to do is this cannot be resolved synchronously. And so effect, again, is trying to call our code. We can actually do run promise, right? And so this results in a promise of a response. Not too dissimilar from just calling a promise unto itself. But again, we get that superpower that the box we described gives us access to, which is that piping, that chaining of behaviors. And so now, what I can do before we do this, we're going to do my first effect. We're going to pipe this. We're going to say effect dot, and then this is going to give us our response. I'm actually going to say response.json, and then I'm going to, we'll start here, effect.run promise. So even the execution can be composed in this pipe pattern here. And so we're saying once we get the response from this fetch call, we're going to get our response. So anyone who's used to fetch is used to sort of unwinding the data, getting the JSON out of it. Then we're going to execute this. And so this returns a promise. So if we look at the value here, I can just throw this in a variable just for visibility's sake. We see we're getting a promise of any, right? Because we don't know what shape of the data is going to be when we get it back from API. So we can just get a little payoff here, a little console.log, and we can see our beautiful API response. And indeed, it is the species of Bulbasaur. Okay, very cool. And so we saw a lot there, right? Not too dissimilar from libraries we're used to using. We're able to make calls, wrap those in sort of an effectful sort of structure, handle errors should they occur. And actually, let's see that error handling. Because if we look at this again back in the playground, we haven't addressed this like really cool or like I think powerful pattern here. How do you handle errors? And so if we back this out, we got our little payoff. We saw Bulbasaur. It's very cute. Actually, we'll see some real Pokemon here in a second. We still see that this program results in an any. If we take a step back, before we execute this, we still have this concept of an unknown exception that hasn't been handled. Because when we run it, we step outside of effect world. We're out into the real procedural sort of code world of JavaScript. So long as we're within this pipe context, we still have access to these errors. And so what I can do in case it errors, Effect has this really cool power or pattern called catch all. What Effect has now done is given me access to all possible errors within my program. We only have one right now, but I can handle any individual error case now in this catch all, or there is catch tags. We're going to talk about what tags are in a second. Haven't quite gotten there, but you can pattern match and handle each individual error that your program could result in. That's an example, but we can just catch all. And so before we saw that this could result in effect dot succeed. I'll explain this in a second. I'll just say right. And so we saw this before. It looked like we had an unhandled error, an unknown exception, the fact that fetch could throw. By the merit of us putting this catch-all here, we've handled and exhausted that case. And so now Effect is saying the program, again, never errors. And it can guarantee that because it's using TypeScript to check, again, all possible code paths and see which terminate in errors and have you handled those errors. Because we use catch-all, we've accounted for that unknown exception error, and now the program is deemed safe. Pretty neat. That's like why we bought into TypeScript, right, is to avoid errors. And so this is kind of cool that we have a convenient way of handling errors should they occur. But we kind of left something. We omitted something. Because the reality is, can't response.json fail? If your request pulls something that returns HTML, XML, and you call response.json on it, you're effectively telling the browser client, trust me, it's JSON. It may not be JSON. So what's the pattern here? We should actually wrap our functions, these potentially dangerous functions, in effect.try, right? Or try promise if it's asynchronous. And that gives us the true representation of our code. So when you're thinking about where do I start applying effect to my code base, I think it's looking at those dangerous operations, those things on the edges. I'm pulling data from the database. I need to transform it. Could it throw? Could it have a data type I don't expect? This is where we want to apply effect. So let's do that. We can say effect.try. Promise. This is asynchronous. We're going to wrap that again. Try promise expects that. And again, we sort of handled all those cases because, again, we have the catch-all. But it's not giving us, I think, again, the true power here of what effect can really do for us. Ideally, we have errors for each of these steps, right? Each step should have its own error that we want to define, and effect can allow us to do that. And so maybe you guys have been playing around with some of the TypeScript features as TypeScript sort of expanded and given us access to things like, well, class, we know that. But there's two steps to this program. We're going to say there can be a fetch error. That's our first step. And what I mean is sort of these modifiers on properties, like read-only or static properties. If you're familiar with Java, you're very familiar with like these annotations or C#. You can do that now in TypeScript, which is pretty cool. So we can say read-only static. This concept of a tag. We'll talk about what that means, or it's actually static read-only. Static meaning we don't assign values to it beyond this initial initialization, and it's only read. In other words, we're basically telling the compiler that this is it's going to be locked in at this value, fetch error. And we have another place where our program can error. It's JSON parse error. So we're going to define that error. And so we're kind of getting a taste of how do you define programs in in effect. We define explicitly the errors that our program can throw as values. Errors as values is the concept that you want to look for. And so now, this try promise, we can actually do an overload on this function. So try promise actually takes not just a function, but it can take an object, which defines the try step of your program and the catch step. So we can catch the original error that this function would throw, and we can actually map that or return now a new fetch error, right? And so now what we see is this step doesn't result in an unknown exception. It results in a fetch error, okay? We can do the same thing for our JSON parsing. So we can make a function called, or an effect called parse JSON. This may be our first effect that takes, or a function that takes a parameter and returns an effect. Totally possible, very common pattern. We're going to say effect.try promise, and we're going to get a response. It's going to be a response of some kind. And we're going to try response.json. We're going to catch, and we're actually going to throw our JSON parse error, a new JSON parse error. And so this function, when given a response, returns an effect of any. As we know, JSON, well, response.json returns any value, but we're saying now it actually can return a JSON parse error, which I would say arguably is like a better type signature for fetch or response.json. We're getting that here. And so we can compose this again, and we can say, and then parse JSON. And now our program again is safe, but if we were to remove the catch-all, we see now our program returns a result of any and a union of fetch error and JSON parse error. So Effect is smart enough to merge those two errors for us, and now we get a type signature saying this program can result in both of those errors, which is pretty cool, right? And so we can actually catch tags, and let's see here, fetch, is it fetch tags, and then I wonder if they're editor slow. We can get now a tag that is the, let me see, live code, always the problem. You know what? We say it's going to be a workshop. We're workshopping it. So they're docs. Ooh, great way to plug the docs. They've set up Algolia so you can search for things. Catch tags. Let's see. They call this expected errors. And so just like I was demonstrating, you can have a function that results in a particular type by defining a underscore tag property on that class, and then you can catch the specific errors. And so the pattern I was trying to illustrate, what they've done better, is just that. Once we define those tags, we can actually have essentially pattern matching functions to capture those specific errors. Pretty useful. We're talking about sealed types in Kotlin. We can do it in TypeScript now. It's cool. And so, pretty neat. And so, let's make this real. This is like some of the patterns of effect, but I think this is still getting a little bit trivial. You have to kind of parse data, right? We need to be able to render the data in an application, and maybe seeing it like in a real application makes it more tangible. But I guess before we transition into Code Sandbox and a real application, any questions, any thoughts, any opinions on effect yet before we jump into maybe a more realistic example? Yeah.
One thing that popped out at me is
Oh, I'm sorry. Questions for the mic. My bad.
right. One thing that popped out at me is the way Effect deals with exceptions.
And compared that to vanilla TypeScript. Whenever you catch, it has to be, I think it's unknown or any.
Right.
But with this, you can actually define what you're catching,
Yes.
and that's pretty big.
It feels like when I think about like languages like Rust and Golang, where errors are really treated like first-class citizens. We don't have that. To your point, it's unknown. You have to do this work. Is it instance of? Is it? Do I actually create a type and parse it that way? It's pretty cool and kind of revolutionary to think of not only as errors as types, but tooling to support handling those errors gracefully. And we'll see some of those things like smart retries based on the error that you get back. Pretty cool stuff. But yeah, really insightful. Yes. Oh, sorry. Yeah.
When you're
throwing those errors, and well, when you're
defining those errors with the tag and all that,
Mm.
can you send other data with it? Can you
Yes.
send a message with it, or okay?
No, absolutely. I mean, these are just classes, right? So they have a constructor. Constructor can spell. So absolutely. Now we can handle values. So you could say what input actually caused this to throw. And so these are just classes. We're just in effect language tagging them with a particular error connotation. And then in this catch, we're essentially using it as an error. I mean, the fact that it is a class and we're treating it as an error is more, I guess, happenstance. But of course, it's a class. We can give it whatever we want, construct it however we want. And so, of course, you could really create, like, I think, a very rich sort of way of handling errors and particular data types that you're handling. Really good question. Yeah. Okay, cool. Let's make it real. Let's do some cool stuff. And so, Code Sandbox. Not my first time in Code Sandbox. Maybe first time trying to drive a demo from Code Sandbox. So we'll be cool. We'll play it cool. But why I'm choosing to do this is so that way when this is wrapped up, I can just share with you guys a link. You can play around with it yourselves. So let's take that same API, that same Pokemon API, but let's really make it effectful. Let's like go all out and really build like a service that can do some cool stuff, have some retrying, and then let's render some of that data in our NextJS application. How many people use React in their professional? Okay. Next.js, keep your hands up if it's still Next. Okay. My people, my brethren, my Next.js folks. Okay. And so Next is great for those who are maybe new to it. It's just like it's React on the server, at least if you're using App Router. It's kind of trippy. If you've ever worked like in PHP, just like, let me just query the database right here, bind my front end code, and just render it right there. It's a great framework. And I say that kind of in a glib way, but I really think it's exciting just sort of what we're seeing with proliferation of good React support. But we're going to build an application now. We're going to define a pokeapi.ts. And I've already installed Effect. So when you're thinking about like how do I add this to my project, there are some things, some extra things that I've added or have imported here. Effect schema. So right, TypeScript is a compile to JavaScript. And so what do we do for runtime? Well, Effect has an answer for that too. If you guys are familiar, has anyone used Zod here? Zod, okay. Yup, Joy, any of those guys? Okay. Yeah, these are good sort of serialization libraries that parse data, give us JavaScript types, and can also encode data to make them usable in other formats. But schema, Effect schema, has its own way of doing that. And so let's actually start with the schema. Effect schema, and I alias it as S just for terseness. We're going to call this a Pokemon schema. And we can define structures using s.struct. So now we're defining an object. The properties we care about, we'll start with just the ID, which is a number, or we'll try to be parsed as a number, and the name of the Pokemon, which would be a non-empty string. Effect has like a great deal of like really powerful decoders, such as like generating a date from a date-like object. Zod can do some of those things, but not necessarily from like particular date formats. And so the Effect team has done some really cool work to make very common decoders just available in the language. And so we've defined a schema. And so how do we get a type from it? Well, type Pokemon is type of Pokemon schema dot type. And so now we can see what it will look like in JavaScript. And so we define something that can be parsed from a string, turned into a JavaScript type. That's what we're seeing here. And so let's do it. Let's say get Pokemon by ID. This is going to take a number of some kind. We're actually going to return an effect of, and so some nice type completion there. Let's say we're going to do effect dot try promise. We're just going to keep it simple. And we're going to make this dynamic. So we're going to use string templates. API.co, API v2, Pokemon, and I'll drop that guy in there. And so now we have our fetch. We're going to chain that, or pipe some operations on there. Effect dot and then. So this is giving us our response. And so we can do our try promise again. Right? And so, actually, I need my response first. Response.json. And so, let's see here. Oh, so now we're getting some type interesting things. And so you can have what can be, at least in, I think I've noticed this in Code Sandbox, the way they have their TypeScript configuration, self-referential types. And so types that are recursive, depending on your TypeScript or TS config setup, depending on the strictness of it, some of these self-referential types effectively to the compiler is saying, this function is defining itself, which is defining itself, which is defining itself, and so it can never quite resolve. And so sometimes we'll get some interesting errors there. So I'm actually going to take this process of parsing JSON, just like we did before, take the response, do the same thing. Let's say JSON. All right. Parse JSON. And now we need to take this JSON at this point, which is a string, and actually parse it as our Pokemon. And so that is simple with, again, effect.and then. Actually, no, I don't think I discussed what and then is. I have a slide. After I get this working, we'll talk about what's actually happening there. Schema has a property or a function on it called decode unknown. And so any value that's deemed unknown can be passed to us, and we can parse it. And so given a schema returns a function that parses your data as your schema. And so this, for someone who may not be used to sort of like piping, may look weird. This is called what's point-free programming. Notice that in this instance, I don't actually reference explicitly the JSON being passed, because what effect is doing is a technique called currying. And so I'll show that real quick what that looks like. You know, we have our toy example here. I think it's helpful to sort of see. Currying is pretty straightforward, right? We take a value, we return a function, and not until it's given its second argument do we actually perform the operation. Right? So we'll let that sit for a second. So add takes a x, returns a function that takes a y. Once we have both, we can actually perform the operation of addition. And so constant increment, what is that? It's adding 1 to a thing. We still have a function here, right? Increment's a function. If we were in TypeScript, we would see that. We can do the same thing we did before. Increment. This is going to maybe anticlimactic because we're going to see the same number. We'll do that. Let's see this here. Right? And so that's what effect is effectively, that sounds so bad. That's what effect is effectively doing for us in this instance, right? We're able to describe, without explicitly passing the value, right? A function now is being returned that's expecting the value that's being passed to us. And so, again, it may look strange if it's like my response to Tailwind the first time I saw it. I was like, ugh. But it's not that bad once you get used to it. And I think the same sort of pattern here, where now what's happening, I can kind of scan the code line by line and see the operations, right? I can see we're parsing JSON. I can see we're decoding unknown as a Pokemon schema. You just sort of read literally as like a series of operations. And so, you know, maybe effect is kind of like your tailwind, but for TypeScript. And so now we're able to get our Pokemon, and so now we can see the type of our effect. It's an effect that results in this Pokemon type and can result in an unknown exception, because we didn't give it any explicit exceptions like we did before in the playground example, but now a new one, a parse error, because that's true. Parsing something can fail. And so we have a parse error and a never. So it depends on nothing. And so this seems all great. This is something we've already done before, but we have never seen, this is literally type never, this idea of requirements. How do we create requirements? In other words, things that our programs depend on. Well, ideally what we're doing when we define these functions, we actually turn them into services, right, that we can inject into our programs. So maybe you guys are familiar with the concept of dependency injection, right? Some of the values there is that when we can code to an interface rather than an implementation, so coding to an interface rather than implementation, we can actually inject a mock that always throws, and now we can test how our code responds to that mock and that failure case. Effect allows us to do that quite simply, and we'll see that here in a second. So we're actually going to define this. This is a convention very common in the effect community. We have a constants of some kind called make. We're actually just going to do our get Pokemon by ID here as a property. I think for extra type safety, I tend to do the const as const. Maybe, I don't know if you guys have seen that pattern. You're effectively telling TypeScript, not only is this thing never going to change, it's never going to change. Okay, that's what we're telling TypeScript right here. And so for things like literal, string literals, we can see that here. And so let's say constant hello, right? What's that type? It's yo, right? Well, actually it should be string. You know what? We're going to do this. A value, I'm sorry, that you have typed as a string, it's literally a string, but because it's a constant, and you do as const, I think this one might already have strict settings on, but depending on your TypeScript configuration, yo would be typed as a string, but now we're able to actually get it as a string literal. The same thing can be done for arrays. Arrays by default are dynamic, right? But now with const, it's literally an array of just a singular value. So I've effectively created a tuple here, right, where it's the value of cool. And so this is nice. It's giving the TypeScript compiler extra confidence that you're not going to mutate this thing. And so as const, pretty neat, right? And so I can start to do things with this array. I can define constant, a collection of things that now to the type system are never going to change. And so that's all as const is doing. And so we're going to get a little wild. I'm going to just type it out, and then we'll talk about what's happening. And this probably is like the twistiest thing that effect does. So bear with me. I know it's getting crazy. It's about to get really gross. So just hang on. Oh my God. Okay. All right. We're going to talk about what just happened to us, and we're going to mourn for us a few minutes ago before this happened. And so what we did was define a service inside of effect. And so we said the Poke API is a class that extends context.generic tag. Actually, just tag. And what it needs here is an identifier. We gave it the string literal Poke API, and that needs to match in some way. This is often used. We'll see this play out in some logging that we'll do later, but this is useful. So for example, I could define a name that I can namespace a type, and so this is an example of just that. This is just an identifier for this, right? And so what we're saying is now in future logs, when this service is referenced, we're actually going to see this in the logs, in the code. So we're able to name a service, be able to get that in logging that effect's going to give us. And these next two parameters, context tag, is a function that returns a type function that takes the service identifier, the class identifier, and then an implementation. And so we could do this in line, right? We could say that this service has a property called get Pokemon by ID, right? It takes a number, like we said, and returns an effect of our Pokemon, the errors that we expect. But that's kind of verbose, and so what we prefer to do is define our functions as they are, the operations they perform, compose them in this sort of make context here, or make constant here, and just use the type of operator. So effectively, we're doing the same thing. And so now we have this service. And so let's actually see this applied. But I'll pause there. I'm throwing a lot at you. Any questions? Anything pop up yet? Maybe we just need to see it used before we ask questions. But anything coming to mind just yet? We'll keep rocking. Rocking means coding. Coding means typing. Typing means rocking. Let's do it. And so we're going to say build a team. Build a team. What is build team? This is the hardest part in programming, naming things. Pokemon teams, by default, very important rule, can only have 6 Pokemon in them, right? And so we'll make that a default parameter here. And we're going to say this program is actually going to depend on the Poke API. And so this is our first time using a service. And so this function, build team, doesn't do anything yet. And maybe I'll actually perform up because that type's getting a little gross. But that final type parameter we see at the very end, the very tail end there, now we've defined an effect that depends on the service. Right? So now effect is recognizing, hey, this program you have depends on an implementation of the Poke API. And so now we're finally seeing that final type argument come to pass. And so now we can do pipe. Pipe is sick. And now we have access to, again, an implementation, or I'm sorry, the type definition of our Poke API. Notice it's not the actual thing. We haven't actually defined the implementation of the Poke API. We've actually just defined a type of it. So this is some of the power of effect, right? So when it comes to testing, I can inject whatever I want. It could be something that does throw a JSON parse error, does throw an unknown exception, and I can test those scenarios, right? So now I can say, we're going to get even more wild. I'm going to say for each, all sorts of ways to constitute an array. This is probably my favorite. So for each of an array that we've constituted from, so just to maybe call this out, if you haven't seen it, you can constant array. You can create an array of arbitrary size. And so array.from will take anything that implements iterable and return to you an array. Length is a property on array. I can tell its length is a property of size 6. I get an array of size 6. So that's what this is doing right here. And so I'm using that to sort of trick or game this for each. So it's going to call this operation 6 times.
Wouldn't it be 0 days though? But the Pokemon IDs start at 1?
The IDs would start at, oh, okay, I see what you're saying. We're not going to start from 0. We're actually going to do some other crazy stuff. But you're right. It would, the index would be very much at 0. We're going to say, what we're actually going to do, we're going to build a team of 6 random Pokemon. 6 randos compose a team of champions to win the Pokemon League. I'm just getting way too nerdy right now. Stop. So what we can do, effect comes with, again, a pretty powerful standard library, random. And I can do random next. Oh, I need to import that. Oh, no. From effect. Next. Range. So I can give it, there's more than 151, but I'm OG, so I only like the first 151. And so we're going to get that. And this is another effect. Again, this is maybe a little bit more nested than I like, but we can refactor it once we get it working. We're going to see a pipe. This is going to return to us an effect of a number, a random number of some kind. We're going to do and then we have our number, and we can perform any operation on it that we want. I'm actually going to do math.floor, because like random in or math.random in JavaScript, we actually get a floating point integer. Pokemon do not exist on a floating continuum. They are discrete values, and so we're going to floor that. And then what we're going to do, we have our random, and we're going to actually get from that effect, and then let's do some new lines. Big new line guy. And then we have our number. We can actually just say get Pokemon by ID from our Poke API. So we'll take a second and talk through what's happening here, because what we're doing is kind of neat. And so we said build team returns now an array of Pokemon. It can result in the error of an unknown exception or a parse error, and it depends on some implementation of the Poke API. The actual work we're doing here is we're saying, hey, Effect, I'm going to use this thing. I'm going to use this API. I want you to give it a name, which is this lowercase version, not this Pascal case. And now, just like everything else, I can call and then to unwrap it, get the value out of it, and perform operations on it. And now I'm saying for each of length 6, we're going to perform 6 operations of this. We're actually going to go out and for a number between 1 and 151, we're going to floor that number first and then pass that to Poke API, get Pokemon by ID. So in theory, we will have 6 random Pokemon. So let's see this. Let's do it. Let's render it in Next.js. So we're going to export this. Gonna need that. Gonna need that. Don't think we need that. Let's do it. And so like I was talking about before, the cool thing about Next.js, we can do asynchronous code right by our React application. No more use effect and foot guns and, we forgot a dependency and now there's an infinite loop. We ain't got to do that no more. It's a glorious times. We can just do cool stuff. So we're going to make this async, and we're going to get our Pokemon. We're going to await build team, optional argument. We can still pipe this guy, and we can do effect.run promise. But wait, there's an error. We said this depends on the Poke API. We never gave it an implementation. We said there's an interface, a type of some kind. But we never actually gave it an actual implementation. So the convention, again, I think is just a kind of a neat one from the Effect team. We have this concept of live implementations. And so we're going to make a static read-only live, which is going to be, we're going to use some crazy words here. Stick with me, I'll explain, I promise. It's actually going to be this dot of new stuff happening, make. And so what we're saying is effectively the live implementation of the Poke API, in other words, we can actually call this thing, is just this code we wrote before. Okay? And so we're using some kind of fancy, class things, and so this is now referring to a tagged dependency, right? So we're extending context.tag, and we're saying we're going to make an instance of this, of literally this implementation of our Poke API. So we have to provide that now to our program. We're going to see this here. Again, we're going to see some crazy stuff, but I promise it's all good. Effect.provide, right? We're going to do a layer.succeed. Oh my gosh, a lot of stuff happening. We're okay. Poke API.live. And, no errors. It's happening. Things are happening. We'll take it. But let's get the payoff real quick before we explain. We're going to do the Poke API, open Pokemon.map. That means it knows it's an array, just like we expected. Yeah, okay. Take that. And let's get some Pokemon on the screen. Be a good React developer. Always use your keys. Name. Let's see what's up. And just like that, our 6 random Pokemon. All right, so what just happened? What are we actually seeing here? So we composed a program that's doing some pretty neat stuff. It's pulling some data down, it's parsing it as we expect, and in fact, it's actually able to be injected with an implementation that now if we wanted to test this program, we could give it an instance of the Pokemon API that throws at any step, any point in time. Let me see. It is, how we feel good on time, Brett? I could do like one more thing. We're good? Okay. Only cutoff point. What I would like to show is some of the retry stuff. I think it's pretty cool. That's what I think Effect gets really sick. And so let me explain this real quick what's happening. And so we said, again, this program depends on the Pokemon API and implementation of it. And so Effect has this function called provide. What this is doing is creating what's called a context and a layer. A layer are a collection of dependencies that our application depends on, right? So we can actually compose multiple things, whether it be a database connection, a service implementation like this. We can compose it and then provide it to our program. And so we have to do this explicitly, just a dependency injection. At a certain point, we have to inject the dependencies we depend on, and this is exactly what we're doing here with this provide step. And then we ran promise, just like we did before. Very cool. All right. So we're going to actually put this behind an API endpoint so we can make it explode sometimes. So we're going to make a new folder. For those who are new to Effect, the coolest thing is you can define endpoints and pages just by defining things on the file system. And so right now I'm defining a route. Let's play it. Whoa. I'm not obsessed with Pokemon, I promise. It's not as bad as it looks. Oh, man. Okay. We're going to call it build team. Now, that's embarrassing. Who's this guy with the Pokemon thing? All right. And so creating endpoints with NashJS, what we can do is define simply the verb that we want to handle from this endpoint. And so build team is the route, so we could go to localhost 3000 /API /build team, and a get request will actually return a value here, and so we can say the request. We're actually not going to need the request, and this will be async here shortly. And what we want to do is half the time we're just going to blow up. Half the time when you request this API, we're just going to simulate just a shoddy network. It's just going to do whatever. Let's make it interactive. How might we do that? How might we half of the time throw an exception or really respond with some bad data, and then half of the time we'll return our actual Pokemon? We already have the Pokemon code, but how might we just handle that first step? Half of the time exploding, half of the time returning some values. Any?
2 services.
2 services? Huh? Effect.red. Ooh, someone's already thinking in effect. Ooh, okay. Any other guesses? Thoughts? I do like random. Random's pretty cool. I'll rock with random. So we're going to make a value should fail. And it's going to be math. You don't have to use effect. We can just use plain old Java. Sometimes you can just use JavaScript, you know? Trust in JavaScript. Like I said, I'm a prisoner of JavaScript. Greater than 0.5. Just like that. And so, if should fail, what we're going to do is return a new response. I've actually really enjoyed libraries nowadays just kind of embracing web standards. So you can just go to the MDN docs and just see how do you return a response from a web server in JavaScript. It's just return a new response. That's super cool. And so status. Yes, status 500, and we're going to do status, oh, no, you're right. And then this is the option status code. Go to status code, or status, that's right. This is fine. You can do status text. And so half the time we're going to fail. The other time, we're actually going to copy this code from our page here. Just going to reuse this and return some Pokemons. But we also have to use, this is where Next gets itself in trouble. They stop using that. The recommended way of returning JSON with Next. They do some nice caching stuff for us. Get that. Gonna get that. Gonna need that. Gonna need that. Okay, very cool. And again, we're gonna return our Pokemon. All right. And so this is cool. This is running, I think. Let's do a little curl -i just to get our headers, and we're going to do HTTP localhost 3000 /API /build team. See what happens. Compiling. Ah! Oh. Ah! Okay. So a little bit more, maybe a little bit more than half. A true random coin flip. Pretty cool. All right. So this is going to be flaky, a flaky endpoint. So let's see this work. So now our Pokemon aren't coming from anywhere. I did install Effect Platform. Effect Platform is pretty cool because Effect is, again, kind of its own little runtime that can target JavaScript, but you can actually run it in Deno, in Bun, in, I forgot the sort of local, it's not, what's the, like the, Slack is built in it. Toro, whatever. It's like the file system sort of browser or node target. Effect can target that too. And so because the runtime is isolated from JavaScript, you can actually use Effect in any environment, even on React Native. And so you can deploy it anywhere. And so what we're going to do is use the Effect platform. We're getting wild. We're going to see a lot of code here. Just rock with me. I promise there's a payoff. It's going to be fun. You're going to tell your friends about it. And so we're going to do Pokemon. Actually, HTTP client dot request dot get. We're going to get HTTP localhost 3000 API build team. And not quite all we have to do. There's some other things, and so this is maybe where maybe Effect and I start to disagree a little bit, but it has good reason why it wants us to do this. We're going to say it's going to actually filter our responses to only those that are okay, right? And then we're going to say the client should expect JSON. And so it makes sense. We're going to request some data at an endpoint. We're saying we only want successful fetches to be passed to us next, and we expect JSON. And so now we're getting an effect of unknown, right? So it's not any. This is Effect's own implementation. It went a little bit stricter than any and said unknown. We don't even know what this type is. And we see an HTTP client error, right? And so we're used to this. We're seeing effects. But now we can do the same thing we did before. We can do schema.decode unknown. Right, and let's get our, let me make sure I exported this. I did not. Schema.decode, like we did before. Pokemon schema. There's a little gotcha here. I wonder if you guys picked up on it just yet, but we'll see here in a second. And so what this is saying is this should result in a singular Pokemon. That's not right. We're expecting an array of Pokemon. So that's what the gotcha was. We can actually transform schemas after we define them, pipe it again, and say this is actually a schema, an array of Pokemon. So that's what we're getting here. And so now we can effect .run promise. This is going to give us our Pokemon, and we need to await this. So now we actually have an array, but oh no! Effect on success. Let's see. Pipe. Only number one. Oh, I see. So this is going to return to us, yes. It's on me. So we try to parse an success. So we try to parse an effect. We have to use our friendly helper and then paste that guy back in there. We're back in business. We're cooking with Crisco. Let's see what next comes up with. Give it a second. So that works. We got our Pokemon from our API. But this doesn't work every single time. Like we said, it's random. It could randomly explode. Oh no! We didn't get a 200. Wouldn't it be great if it just handled it for us? If it fails, just try again. With effect, because of this whole piping stuff I've been selling you guys on the whole time. This is a big payoff. I got to nail it the first time. Woosah, we got this. Effect dot retry. Is that it?
Well, with the tagging, would you be able to like retry only if it's an API fetch error?
You could.
Versus a parse error?
That's right. So with effect.retry, there is retry until or while. There's a few different ways of handling it. So while the error is anything other than, let's just say a 500, a catastrophic server error, just retry, you know? We can do stuff just like that. But we can give effect, because it's not just, I think if you guys have ever actually written retry logic, you just don't eagerly retry. That's called DDoSing yourself. You don't want to do that. We want to back off. So we can do effect.schedule and actually exponential. Actually, I'm sorry, schedule.exponential. Exponential. Let's just say 200 microseconds. And so what's going to happen now, this should never fail. So it's waiting. It retried until it worked. Pretty cool, huh? You know, that's effect. All right. That's all she wrote. I don't know. Any questions? Any thoughts? Yeah. Oh.
What's handling the what's handling not displaying the error?
Oh, if you wanted to display an error to the user?
No. Like you before you put the retry, effect retry in there, it would throw the 500 error. So that's essentially displaying it.
So yeah, this is the next.
Is that effect taking care of all of that?
So this is actually being rendered by Next. This is the dev compiler, and so rather than just blowing up the server, it's actually the web server's catching it, displaying an error to you, and starting the server back up. But
effect is taking care of that in this sense.
This is Next handling it. Technically, if this were a runtime, if this were really running, my server crashed, so I didn't handle the error. This is me kind of acting. Maybe you could say lackadaisical towards errors. The appropriate thing I would say is you probably really do effect. So eventually, if it were to fail, we could do effect.catchall. The effectual thing to do would be succeed with what's a sensible default for an array, an empty array, right? And so even after it fails, let's just say I can even tell it how many times it should try. So you could say times, only try 5 times. So it's going to fail, wait 200 milliseconds. Fail, wait 200 milliseconds. Up the 5th time, it's just going to result in this error state because it's going to catch the HTTP endpoint is going to respond with the 500. We said you can only handle 200s. And so this is an error. Rather than exploding, I return an empty array. And so now I'm just going to get an empty array of Pokemon. So initially I wasn't handling it, and so really what we were benefiting from is I'm running a test Next application, a mock server or dev server that's gracefully handling the error. I was doing no error handling initially, and so that was really just more Next doing that. So, but this is real error handling, I think. And so rather than throwing, we return sensible default values is the real pattern here. We can retry, that's what we're getting for this, is this retry behavior where we're going to try, we're going to back off, try, back off, and then once we immediately fail or we exhaust all those options, we return a sensible default. And so that would be the recommended pattern. But yeah, I mean, like we saw, this endpoint can indeed not be our friend. There we go. And so
without the retry, it's going to return the exception from the fetch,
That's right.
which Next.js would.
Right.
That's why it's showing the Next.js
Status error. That's right.
Because it's an exception for fetch. Yeah.
That's right. That's right. All right. Awesome. Thank you,
You
guys.
have the catch-all,
Yeah.
and you made the route always just do 500.
Mm-hmm. Oh, yeah.
You would eventually get a different exception.
We can see that.
Yeah, that'd be cool.
So we can just always going to throw, right? So no matter what,
Yeah, just
I'm just
fill all
gonna
the time.
fill all the time. And so what we should see is just kind of hanging out, because effect is retrying in the background. And eventually we're going to result in an empty array.
Yeah.
So we're not going to render anything on the screen, right? So there's no Pokemon. It's an empty array, so the application can render about that, but we're trying 5 times, and so, but exponentially backing off. So maybe I'll turn off the retry so we can just see that. Yeah, I don't know what this exponentially
Yeah,
is.
I was curious what would happen without the catch-all as well.
Without the catch-all? Oh, not a good time for anybody. That's that next error page. Right.
All right.
Now otherwise, it's empty page, right? No Pokemon, empty array. What is a map to that? And so this retry is what's saving our bacon. Yep. And so, yeah, it's just going to sit here and spin out. Well, 5 times 200 exponentially squared. It's going to sit a minute. It's going to sit a minute, right? And so. But yeah. Very cool. Yeah, if you're interested in more effect, I can share this with Brett. I'll definitely drop it in NashDev. A lot of really great resources from the Next team. They have a really active Discord. Like we use their site. Very awesome sort of resources. Ethan Nasir, I think he's maybe like 18, 19 years old, but he's like kind of killing it in the effect game, making some really great content on YouTube about this library. And then Sandro Maglione, he helped me sort of craft some of this demo, and he actually has a course that he just launched on the very basics of effect. And so I thought this kind of left you desiring some more effect. He has a really great course, and I'll make sure that link also gets shared in NashDev. But yeah, thank you.